Hi, we're MicroPALS. This is a microwave permafrost active layer sensing, and this will be presented by Ella, Kate, Honor, and Bruno.
Hold on, I just need to.
So the objective of our mission is to gain a clearer picture of the Earth's permafrost, specifically by combining the following. And we're hoping to create a program that can support other satellites to collectively gather as much information on permafrost as possible. Specifically, we will be looking at soil moisture content and depth of active layer, then combining the pre-existing data to get a full picture. Permafrost must be frozen for a minimum of 2 years to classify as permafrost, although there is a record of permafrost that has existed for thousands of years. However, it's important to take measurements frequently so we can gain a picture of potential melting of the permafrost. Therefore, we're sort of aiming to take measurements every 6 months. Although there is already information about permafrost, we are aiming to use microwave sensors to allow greater knowledge, as these provide a deeper measurement of permafrost.
So we will be measuring the raw data using satellites that are sensing the soil moisture and the layer depth. This will create our level 0 data, and then from there, ground stations will convert the data into level 1 and 2 products to be used within the algorithms. The algorithms that we plan on using, one is the ALOS2 mission BARC algorithm to convert raw data into products. And we're currently still looking into the literature around this and possible other algorithms that can be of use.
So to justify our mission, to directly quote ESA, permafrost plays an important role in the global climate and is also one of the components of the Earth system that is most sensitive to global warming. So it is an important topic that does require focus. There are already programs focusing on permafrost, however, to justify our proposal specifically, we are focusing on the use of microwave rather than optical sensors. This allows a clearer image and it doesn't interfere with clouds in the same way. There is currently little information as well on microwave sensing gathering information on permafrost, so we're aiming to fill that gap.
Okay, so the mission, assumptions, and technical requirements. As mentioned before, we're going to use microwave remote sensing. And for this, we're going to try and use active and passive. So for the passive sensing, we're going to use pre-existent data from satellites that are already up in space to get things like the brightness, surface temperature. And we just thought that would be probably the most efficient way to get these kind of more general readings of the surface. But then our kind of main focus of the mission is to get better active layer depth readings, because that's really important for determining the kind of state of ground permafrost. So for this, we're looking into using SAR and INSAR, potentially LMP band SAR, but we're still kind of at the stage of figuring this out, and to do with the conditions for the observations, the orbits, altitude, that sort of thing. But we've pretty much narrowed it down to we're going to be putting these active microwave sensors up in space. And then, yeah, so this is echoed by Bruno earlier, but like the mission architecture is the plan is data going into the algorithms down at the ground stations, well, afterwards going to the ground stations, and then being processed through this, and then eventually for publication. And hopefully this data could be available on a really wide scale so that it could be used for further research in loads of different ways.
So for mission performance, the constraints are obviously very limited at the moment because we're not quite sure what we're doing yet. As Ella kind of pointed out, we've got our outline of our methodology, and we will be cooperating with other ESL bodies to use our data. The details of the algorithms, as Bruno said, we are likely to be using the BAC algorithm that was used in ALOS2, which is the Japanese one that is actually one of the examples that we're going to be using as like an example of similar instruments. So ALOS launched 2 optical instruments conducting L-band SAR measurements on the frequency of 1.2 gigahertz. It's got a 1 meter resolution and up to 500 kilometers swath range. So that's kind of what we're aiming for, but we're just doing it for the specific soil properties. Similarly, Cryosat, which is by ESA obviously, they also use radar, so they'll be a really useful example of using radar for quite precise measurements. Programmatic elements, we need a launch, satellite operation, algorithm, calibration, and ground stations for processing data. We also need ground fieldwork to ensure the data is correct. And as I say, the similar missions would be probably Cryosat or ALOS. I don't really have costings yet because that's quite difficult to find, but launchers you could like refer back to Cryosat and ALOS as to what they used to be very similar to that probably. And that is our references. Thank you very much for listening to us.
Thank you.